Hello, mathematicians. Today we are going to find the probability of independent and dependent events. Independent events are ones that one does not affect the other. Okay? So, however one thing occurs does not affect the next. So if I flip a coin, that has no effect on when I go to spin the spinner. Okay? They do not affect each other. So let's take look at some examples. A spinner has three sections, A, B, and C. A number cube, which is also a dice, is rolled. So two things are happening. We're rolling a dice and spinning a spinner. Okay? Two different events. We want to find the probability that we land on a 4 and we spin an A. Okay? So there's two things happening. So two probabilities. So I'm going to first find the probability of landing on a 4. So think of our dice. How many 4s? 1 4 out of 6. Now let's switch gears and think of our spinner. We want an A. How many A's? 1 A out of how many spots? 3. And we are now going to multiply these two probabilities together to give us the probability of them both happening at the same time. How do we multiply fractions? Straight across the top, straight across the bottom. So our answer, 1 over 18. You have a 1 out of 18 chance of rolling a 4 and spinning an A. Find that as a percent, please. 6% chance. So if you have both a dice and a spinner, and you do both of them at the same time, you have a 6% chance of getting a 4 and an A. Try this next one on your own. Find the probability of rolling an odd number and spinning a B. Let's see how you did. The odd number. What was the probability of spinning or rolling an odd number? There are 3 odd numbers on the dice out of 6. Now what is the probability of a B? There's 1 B out of 3. What did you do next? Multiply. And how do we multiply? Straight across the top, straight across the bottom. And we get 3 over 18. Simplify, you can divide these both by 3, and we get 1 out of 6. You have a 1 out of 6 chance of rolling an odd and spinning a B. That as a percent is 17%. So find the probability of each one, multiply, and simplify. The next set of examples are dependent events, meaning whatever happens the first time will affect what happens the second. For example, if I have a case of markers, and one student takes the blue, the next student can't choose it. So the next student's options are affected. Right? So the first changes what the second can do. So I have 4 blueberry, 6 raisin, and 2 plain bagels. We pick 2 bagels without replacing the first. So I take one, and then I take another. Right? The first one is not put back. Find the probability that I pick a raisin, then a plain. So raisin first. How many raisin are there? 6 out of how many total bagels? 12. 12 total. Now, one raisin is gone. And now I want to pick a plain. So how many plain bagels are left on the table? 2. And since I took a raisin out, how many total bagels are left this time? 11. This time there were only 11 bagels for me to choose from because one of the raisins was taken out first. Again, we can multiply, and I would recommend simplifying a diagonal to make it a little easier. Which diagonal can we simplify? The 2 and the 12. What can I divide 2 and 12 both by? Divide by 2 is 1. Divide by 2 is 6. Now how do I multiply fractions? Straight across the top, straight across the bottom. We get 6 over 66. Divide these both by 6, and we get 1 over 11. Go ahead and find that as a percent. There is a 9% chance that you will pick a raisin, then the plain. So remember, since I didn't return the raisin, the total number on the table changed. Try this next one on your own. Find the probability that you pick a plain bagel and then another plain bagel. Let's see how you did. So I'm starting with a fresh table of bagels listed above. What's the probability that I pick a plain? How many plain are there? 2 plain. Out of how many total? 12. Okay. I take one of the plains. So now when I go back to the table, how many plain bagels are left? One of them, because I already took one. So there's only one of these bagels left. So there's one bagel left out of how many on the table this time? 11. I took one bagel, so there's only one plain left. And since I took one, my total is now 11, since I did not return it. How do we multiply? Straight across the top, straight across the bottom, and we get 2 over 132. And we can divide these both by 2. 2 divided by 2 is 1. 132 divided by 2, 66. There is a 1 out of 66 chance of choosing plain, then plain again. Find that as a percent. 2% chance. So there's a very small chance of randomly going up, closing your eyes, grabbing a plain bagel, then grabbing another plain. See how this problem could look different. This time the first bagel is replaced, then another is picked. So I pick a bagel, put it back, pick another bagel. Find the probability that you pick a blueberry followed by a raisin. So blueberry, how many blueberry are there? 4 out of how many total? 12. So I pick it, put it back. Okay. Has the table of bagels changed at all? No, because this time I replaced it. Before, we did not replace it. Now we want a raisin. How many raisin are there? 6 out of how many? 12, because I replaced it. So you need to pay very close attention if it is replaced or not replaced. If it's replaced, it doesn't change the group. But if it's not replaced, it does change the group. I would do some simplifying. Which diagonal can we simplify? both of them. 6 and 12 we can divide by 6 is 1. Divide by 6 is 2. 4 and 12, what can we divide by? Divide by 4 is 1. Divide by 4 is 3. And how will we finish this? Straight across the top, straight across the bottom. 1 times 1, 2 times 3. You have a 1 out of 6 chance of picking a blueberry, putting it back, and then picking a raisin. Find that as a percent. 17%. So you're going to find the probability of each one. Pay close attention if it is replaced or not, and multiply them together to get your final probability. Nice job today, mathematicians.